Hi champs, welcome back, and in this video we will continue understanding the various classifications. In the previous video we learned about combination, and here we are going to discuss on exactly the opposite, decomposition. Combination, two reactants combine to form one product. Decomposition, one reactant, it decomposes to give simpler products, two or more simpler products. So that's what is decomposition all about. So when a single reactant breaks down to give simpler products, this is a decomposition reaction. And example is when ferrous sulfate is heated, it gives ferric oxide, sulfur dioxide and sulfur trioxide. Now I would request you to write it down in your rough note and closely try to understand how this is balanced. Just try to understand how this is balanced, because it's a very simple reaction, but it's a good exercise. When you see everything, you see each and every element there and see how it gets balanced. Okay, just do that. It's interesting. And another example is the calcium carbonate. When it is heated, it gets decomposed and it gives calcium oxide and carbon dioxide. Now let's have a small revision. What is quicklime? CaO. What is slaked lime? CaOH twice. And what is CaCO3? Calcium carbonate. That's called the limestone. Right. So the CaCO3, when it is heated, it gives quicklime and CO2. Remember, when decomposition reaction is carried out by heating, it is called a thermal decomposition. Now see, decomposition can happen by heat. It can happen when, in the aqueous solution of that particular compound we pass electricity, then that is called electrolytic decomposition. Or when it is exposed to sunlight, then it decomposes. That's called photo decomposition. So we are going to see some examples. Lead nitrate, when it is heated, it gives lead oxide, nitrogen dioxide and oxygen. This is an example of thermal decomposition, because when you heat lead nitrate, you get this reaction. You get to observe this reaction and these products. So light can also be a factor for decomposition. Silver chloride turns gray in sunlight. Now this was used in photography 2-3 decades back. Now we have the digital cams, so we don't use this anymore, right? But still, I remember, we used to have those films and we load that in cams and a lot of things. It was much more interesting. But nowadays it has become very simple. Take a cam, click it. But this reaction is the basis for the photography 2 or 3 decades, till 2-3 decades back, this was used. Even till 2010 maybe, I'm not sure. But then another reaction for photo decomposition is silver bromide. When silver bromide is exposed to sunlight, it gives silver and bromine. Okay. And we have discussed earlier that any reaction that releases heat is exothermic. Heat is a form of energy, and in exothermic reaction, energy in the form of heat is released. Okay, fine, that's great. And there are reactions where energy like sound, light and heat are absorbed, and these are called, oh wait, okay, I don't do that, you can't see that word, okay, endogonic reactions. Now I think it's visible to you. So what are endogonic reactions? Endogonic reactions are those where the energy is absorbed. So we are going to discuss about one endogonic reaction, that is endothermic. Endothermic means the heat is going to get absorbed by these reactions. An endothermic reaction is any chemical reaction that absorbs heat from its environment. The absorbed heat energy provides the activation energy for the reaction to occur. Let's go ahead and have the example. 2 grams of barium hydroxide in a test tube and add 1 gram of ammonium chloride. Mix it with glass rod. Touch the bottom of the test tube. All you find is it's cold. It's not hot. It's cold. So why is it cold? It's cold because this reaction is an endothermic reaction, and the heat gets absorbed. The characteristic of this type of reaction is that it feels cold. Okay. Another explanation to understand the exothermic reaction is when the total energy of reactants is more than the total energy of the product, the difference in energy is released as heat energy. Now, interesting. We had something that we discussed earlier, right, called the law of conservation of mass. The same way, we have the law of conservation of energy. I'm sure you would have come across this in your earlier standards. And law of conservation of energy states that energy cannot be produced nor it can be destroyed, but it can be converted from one form of energy to another form. Now, the total energy of the reactant side must always be equal to the total energy in the product side. Sometimes what happens, the total energy of the reactant side is slightly higher, and the total energy of all the products is lower, and there's a difference in the energy levels, correct? But energy cannot be destroyed. So what happens? That remaining energy is released as heat energy. Now you get the point? So the total energy is always the same with the reactants and the product side. The total mass should always be the same with the reactant and the product side. You get it right? That's why in exothermic reaction the energy of the product is less, so the remaining energy from the reactant side is released as heat energy. Thank you, and let us meet in the next video.